we are a team from Venezuela and we are here to present the project, the Interactive Whiteboard and Table Revolution.
The use of computers and internet has been beneficial to both students and teachers. Internet has unlimited resources to different topics in a classroom. There are powerful tools for teaching and learning as interactive whiteboards and tabletops. An interactive whiteboard, or IWB, is a display panel where the digital image can be controlled by touching the panel instead of using a mouse. On the other hand, the tabletop is a surface that controls the computer using the same interactive mechanism. However, most schools in the world still use conventional methods like using a common blackboard and chalk or even a whiteboard and marker. For years, IWBs have been used widely in primary schools of the UK, Australia, Japan, and other European countries. Only recently they have started being used in the USA and Latin America. In Venezuela, IWBs are only found in large companies and universities. Most primary schools are using only projectors to make presentations without interactivity, which limits the uses of the hardware. This is because Venezuela, like most other developing countries, doesn't have the possibility to invest on these devices because of their high costs. These situations mean that children do not have the same learning opportunities, and this affects the primary education for everyone Millennium Goal. Furthermore, by ensuring quality in education, we can raise awareness in children of other Millennium Goals like environmental sustainability or combating widespread disease. Our solution. After looking through many possible solutions, we had the idea of building a low-cost interactive whiteboard in order to make this equipment more accessible to schools and offer equal global opportunities.
Our whiteboard was built using two Microsoft LiveCam VX7000, a regular whiteboard, and an USB hub. When the user put the finger over the surface, the webcams capture it. These images are processed by the computer in order to move the content. The software was developed using the UCV library. It is responsible for the digital image processing. It was compiled with the Mono project. It allowed portability to other operating systems. For example, Canary. It was developed by the government of Venezuela for educational purposes.
Teapot, cabbage, pear, knife, kettle, glass, cabbage, teapot, cabbage,
Once we got the low-cost IWB up and running, we thought, The IWB is a powerful tool for the teachers showing different class subjects and occasionally bring up a student to solve a short puzzle or exercise. There has to be a way to get every student interacting with a special device that can be easily controlled with their bare hands. So looking around the internet, we found a way to make a low-cost tabletop that works with infrared light, a webcam, and a projector. A low-cost tabletop is composed by an acrylic board that's been framed by a series of infrared lights, and under the acrylic there is a sandblasted glass that works as a projector screen. Now inside the tabletop, there's a projector that projects the image of the computer throughout the tabletop. And there's also an infrared webcam that tracks the infrared points that are generated when the user touches the acrylic board. Our tabletop works with an open source multi-touch library known as TouchSlip for the touch events triggered by the user. At this point, we counted with low-cost devices to create an interactive lab that can be implemented in most schools in Venezuela. Now we found ourselves on another situation. How can we make teachers prepare interactive classes using all these devices? So, what we have so far is a prototype of a low-cost interactive whiteboard that helps the teachers make their classroom lessons more dynamic and attractive to students. We then built a low-cost tabletop that can be used by groups of students at the same time, solving puzzles and learning together different lessons of any nature. Finally, we developed a small pool of educational software that can be used on these devices, and a dedicated website that helps the teachers to prepare his or her classes more easily. Our goal now is to run a pilot study with a small number of schools in Caracas. Each school would have an interactive classroom which contains an IWB and several tabletops. We will regularly visit these schools to monitor the use of the equipment, and depending on how the pilot goes, we may then look forward to expand throughout the city and perhaps the country.